Is a triangle, and we are asked to find the area of the triangle and what type of triangle is formed. So looking at this is a coordinate geometry. We have 3 coordinate points. We have P, so we have -5 and 7, and we have Q, -4, -5, and we have R, 4, 5. So let the coordinate point of P, -5 and 7, be equal to x1 and y1, and the coordinate point of Q, -4 and -5, be x2 and y2, while that of R, 4, 5, be our x3 and our y3. So for us to find the area, the formula for finding the area of a triangle with coordinate points, area of triangle PQR, is equal to half, bracket open, we have x1 times y2 minus y3 plus x2 times y3 minus y1 plus x1, x3 times y1 minus y2, brackets close. So we'll be using this formula to get the area of this triangle. So we have 1/2. Our x1 is -5 times our y2 is -5 minus our y3 is 5 plus our x2 is -4. So we have -4 times y3 is 5 and our y1 is 7 plus x3. x3 is 4, our y1 is 7, and our y2 is -5, making this positive. So we have 1/2 -5 minus 5. So this is -10 plus -4. 5 minus 7 is -2 plus 4. 7 plus 5 is 12. So we have 1/2 -5 times -10 is 50. -4 times -2 is 8. And 4 times 12 is 48. So this will be equal to 1/2 times 50 plus 8 plus 48 is 106, which is equal to 106 divided by 2. So this is 53. So the area of this triangle, find the area of triangle. So the area of this triangle is 53. So the next question, we are asked to find what type of triangle is formed. So we are going to be using the formula for distance to determine the length of each of these triangles. Length of PQ, length of QR, the length of PR. So the formula for distance in a coordinate geometry is equal to square root of x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. So for PQ, we have PQ equal to, so our S2 now becomes -4 minus our x1 is -5, which is +5 now, all to the power of 2 plus our y2 is -5 and our y1 is 7, all to the power of 2. So simplifying, -4 plus 5 is -1, is +1, sorry, all to the power of 2 plus -5 minus 7 is -12, all to the power of 2. So this is equal to 1 times 1 is 1 plus 12 to the power of 2 is 144. So this is equal to root 145. So line PQ is root 145. So we'll be finding for line QR. So QR is equal to S2 is 4 minus, and our x1 is minus 4, which is plus 4, all to the power of 2, plus our y2 is 5 minus y1 is minus 4. Okay, minus 5, sorry. So this is equal to 4 plus 4 is 8. 8 squared plus 5 is 10. So we have 10 squared. So this is equal to 8 to the power of 264 plus 100, which is equal to root 164. So the distance from here to here is root 164. So we'll be finding the distance from P to R. So PR is equal to our x2 is 4 plus our x1 is minus 5. So we have 5 plus our y2 is 5 and our y1 is 7. So we have 5 minus 7 all to the power of 2. So simplifying from here, we have 4 plus 5 is 9 squared. 5 minus 2 is minus 2 squared. So 9 to the power of 2 is 81. 2 to the power of 2 is 4. So this is equal to root 85. Now, looking at the distance, we have root 145, we have root 164, and we have root 85. That means they are not equal. So not equal in distance. So we conclude that this is a scalene triangle. So this is a scalene triangle.